When we were working with vectors, we talked about how we could index individual elements in vectors. The same is going to be true in matrices. We'll be able to index an individual element in a matrix. The one difference is that when we have a matrix, we're going to have to specify 2 dimensions to locate an individual object, an individual element. We're going to have to specify both the row and the column where that element is located. So, for example, if I ask for an element that's at location 3, 2, I mean row 3, column 2. Again, rows are always going to come first when we're talking about matrices. So I have the rows, right, numbered 1 through 5. Also, the columns are numbered 1 through 5. So to figure out which element I'm referencing here, I look at row 3, and I look at column 2, and I look at where they overlap, and so this will give me the element 3. I can also access a complete row or a complete column using the colon in place of a numeric index. So the colon in this case just kind of means all of. So this would be row 3, all of the columns. So I would get back a row vector. I could likewise specify a column. So this would be all of the rows in column 3. So I would get back a column vector. Now we can see what that might look like in MATLAB. So here's the matrix we just saw. And again, I can ask for an individual element by specifying a row and a column. I can ask for a row by specifying the row number and then saying give me all of the columns in that row, and you can see I get back a row vector. Or I can say give me all of the rows in column 3, and I'll get back a column vector. And we can see that this is in fact column 3 from our original matrix. So that's how we access elements, rows, and columns